All right, geometry, here is lesson 2. And we're going to talk about arc length. Now, like we just talked about, kind of like a pizza, we would be taking a look at just the distance of that pizza crust. Okay, that's what we're looking at. So we're looking at only a segment of the circumference. So how to find that is the length of an arc is a portion of the circumference. So if we take the entire circumference and we divide it up, that would give us the length of a certain part of an arc, and that's what we're looking for. And that's why our formula is, the arc length formula is kind of like this fancy L equals, okay, X. X is just representing the degree measures of the arc, which is also congruent to the central angle. So we'll go back and forth between the two. C represents circumference, and we have two different formulas. One's represented using radius, and the other one is represented using diameter. So it's just going to be, and that actually is incorrect. I just realized that. That would be 2 times diameter equals circumference. No, that is 2 times, that's diameter times pi. Okay, so looking at that, that's diameter times pi would end up giving us our circumference. So let's go ahead and take a look at our first problem. Okay, to find the arc length, we're going to round to the nearest hundredth. Remember, that's 2 decimal places. Okay, and we need to find if, well, no, sorry, EB. So EB is this distance right here, is 15 centimeters. Okay, and we need to find the length of arc. Remember, this is the, whenever you see kind of like this, the shape, that's the arc CD. So from C to D, that's what we're looking for. Okay, but the information they gave us was kind of completely well, I mean, the radius is going to be 15 all the way around. So given that piece of information, we know that the radius equals 15. Okay, well, let's go ahead and write down our formula for arc length. Okay, so it started off with that fancy L. Yes, that's an L. Okay, and then X represents the angle, the degrees of the measure of this part right here. I don't have that right now, but what I do know is that 68, this measure, there's a diameter here, BD. So what I can do is, since there's a straight line and I know this measure is 68, I can go ahead and take 180 and subtract 68 degrees, okay? And when we subtract that, that's going to give us 112. So this is going to end up being 112 for our central angle. Once I know that central angle, remember the central angle is the same as the arc measure, okay? And the measure of the arc is what we're looking for, the degrees measure of the arc. That's represented by X. So we have that piece of information as well. Now we have enough information, we can go ahead and substitute it into our formula, which is just going to give you that fancy L, X times the circumference, all divided by 360 degrees. Okay, so the arc length is going to end up being 112, because we know that the measure of the arc is, the degrees is 112 times our circumference. Now our circumference formula, because we were given radius, it would be better to use 2 pi r, and then our radius is going to end up being 15, all divided by 360. Okay, now I'm going to use my calculator on the computer, because I realize that you guys might have the same calculator. But also I noticed that this calculator says standard. I don't know if all of yours are going to be the same, but you can go to this box right here with the 3 slashes, and it'll give you other options. So we can go ahead and go to scientific. And the reason why we're going to scientific is, notice how we have a pi button. But there's also trigonometric functions that you can use for other things too. So what we're going to do is we're going to go ahead and multiply everything in the numerator. Okay, so that's going to end up being 112 times 2 times pi times 15. That's going to give us that crazy number. Okay, and then we're going to divide everything by 360. Okay, and you're going to end up with 29.32 centimeters. Okay, and the reason why we would stop there is because we would go 3, 2, and then 1, That number does not round up. Remember, we need 5 and above to give it a shove, or 4 and above to give it a, nope, 5 and above to give it a shove. Okay, and in this case, we're gonna stop there. All right, and we are talking in the first dimension, so it's just to the first power. You don't really need to have that. We would only need squared or cubed if we were talking area or volume. All right, so there is for that problem. Let's go ahead and take a look for the next one. Okay, so we're going to start off with, I'm always going to write down my formula for arc length first. So it's going to be x times the circumference all over 360 degrees. We need to find some information out. They tell us, and we need to find, this time we're looking for the length of FED. Okay, F to E to D. Okay, so this is actually a major arc, and they used 3 capital letters. If they only said FD, we would go the other direction, and that would be over here, but they didn't. They actually went the other direction because of the letter E. So this one we know is going to be greater than 180 degrees. So let's go ahead and take a look and see what we can do. Okay, some information. They tell us that this is 90 degrees because of this little perpendicular box right there, I can tell. Next, we have all of the information except for this central angle right here. So if I don't know what that central angle is, I can go ahead and add everything else up and subtract it from 180 or 360 degrees. So we can take 360, subtract 47, subtract 80, subtract 90. Okay, in fact, I'll do that right here with you guys. So that's 360 minus 47 minus 80 minus 90. And that's going to equal 143 degrees. So this is 143 degrees for our central angle. Our central angle also equals the arc, the degree of the arc. This is 90. Whoop, that's outside of the filming zone. So if I know this is 90 degrees, this is 143, I can add those together and that gives me my inside measure, which is x. So remember we talked about the degree of the measure of the arc is x. Now we're going to end up with 90 plus 143. Okay, and that's going to end up giving us x equals 233. Okay, so that's going to end up being 233 times our circumference. Okay, and our circumference on this one, we kind of skipped over it. Sorry about that. Let's try blue. Okay, FG. So we know from F to G, which is in our inside, it is another radius. If we were given the diameter, we can use the formula for diameter. Okay, but in this case, their circumference is 2 pi r, because our radius, whoops, equals 27. Okay, so 2 pi times the radius, which is 27. Too many parentheses. Let's try that again. Okay, all divided by 360 degrees. 360 degrees is not going to change. You're going to be working with a circle. Okay, now we're going to multiply everything in the numerator. So that's 322 times 2 times 27. I'm going to press enter right there, and then I'm going to multiply it by pi equals that crazy number and divide it by 360. So we're going to end up with 109. I wish that stayed up here, 0.79, but because of that 9, it's actually going to round up. So that 9 is going to round the 7 up as well. So that's going to end up being 80. Don't forget your units because it is talking in yards, and that would be the length of FED. Now there is a difference between the length of FED and the measure of FED. whenever you see the word or the letter M in front, that just means the measure. You're actually looking for the degrees, which we already found. It's 233 degrees. But when you're seeing length, that's an actual distance, like a part of a circumference. Whenever you see measure, that's talking about the inside angle measure that they're, or the arc measure from 2 points on that circle. Okay, and that's what that's talking about. Two different things. All right, if you have any questions, don't hesitate to ask. I'm on for Zoom tutoring at least 2 more times this week. There is some optional practice below. You're welcome to ask me any questions on that. There are some answer keys down below, and I think I'm gonna probably put the worked out lessons that I just did all the way at the bottom too, if you would like to access that. Okay, but please, if you have any questions, please let me know. It's hard teaching you guys this way because I can't see or help you in the ways that I would wish. So I'll leave you at the end with this smiley face, and we can talk about the circumference of the smiley face. Okay, hopefully you guys are having a great day. Have a great week, and I'll see you guys next week. Bye.